Hey guys, alright, so in this video we're going to talk about what's called Bohr models, and these are just drawings or sketches of atoms and the different parts that make the atoms up, okay? We call those subatomic particles. And right up here, okay, to my left, I have an example of a Bohr model, okay? We'll be referring to that as we go, but this essentially just includes the different parts that make up an atom, or its subatomic particles, and we're going to talk about all those today, and then how to put those things together, how to use the periodic table to help us draw a Bohr model and to see what parts make up an atom. Okay, so we're going to go ahead and we're going to define a few words real quick. Okay, we're going to start with the word proton. Proton. All right, and I'm going to cover really three words as we go here, okay? First word being proton. Protons are positively charged particles. Charged particles in an atom's nucleus. Okay, so the nucleus, that would just be the center of the atom, okay? So if we look at our example here, protons are positively charged, right? Positively charged. And that's what those plus signs represent, okay? Those would be the protons. Notice how they're in the center, okay? They're in the center of that atom. All right, and one thing I use for myself to help me remember that protons are positive is proton and positive both start with P. All right, that's how I remember that. Okay, I don't know why I have negative signs there. That should not be the case. We use zeros there. Okay. Next word we want to define is neutrons. Neutrons. And you might notice right off the bat, in the word neutrons, you might also be able to see the word neutral, okay? If your car is parked in neutral, it's not going forward, it's not going backward, it's just hanging tight right in the middle, okay? It's stationary. Same thing with neutrons, okay? Neutrons do not have a positive or negative charge. They are neutrally charged, okay? Neutrally charged particles in an atom's nucleus. All right, so again, we look at this picture. I'm going to use zeros to represent neutrons because, again, neutrons aren't positively charged. They're not negatively charged. They're neutral. And I think of the number 0, right? 0 is not necessarily positive. It's not necessarily negative. It's just kind of right in the middle. Okay, so that's why I use zeros to represent neutrons. They are neutral. Okay, and then the last one we want to define, the last subatomic particle we want to talk about is electrons. Electrons. Okay, and I don't really have a tip to help you remember this, but they are negatively charged particles. Negatively charged particles around the nucleus, okay? So not in the nucleus, but they're actually buzzing around. And you can see in my picture here, I kind of have a ring going around. That's where the electrons are going to be buzzing around, okay? So negatively charged particles around the nucleus. And I probably even should have said outside the nucleus instead of around, but you get the idea, okay? So those are the three different things that are going to make up an atom, okay? Even though we would say atoms make up all things, well, technically atoms are made up of things too, but we won't go there, okay? So make sure we have these three words written down. Okay, the definitions for those. And I'm going to go ahead and I'm going to erase this. So if you need to pause to get that stuff written down, go ahead and do that. But I'm going to erase. Right. And we want to go ahead and use the periodic table to help us draw Bohr models for elements, okay? And I have a few examples up here. This video is only going to let me record for 15 minutes. So I want to make sure I have enough time. I have about 10 minutes left here, okay? So I'm going to be quick. This example, let's take a look right here at this example. I want you to keep in mind, take a look at it. How many protons do I have? How many electrons do I have? How many neutrons do I have? Okay, so remember, protons are positive, so how many plus signs do you see up here? I see 2, right? 1, 2. So there's 2 protons. How many neutrons do I have? So those are neutral, so I'm using a 0 to represent our neutrons because 0 is neither positive nor negative. Okay, I see 1, 2. Okay, 2 neutrons. And then how many electrons do we have? How many negatively charged particles do we have buzzing around the outside? I see 2 again, right? 1, 2. So that's how we want to diagram our atoms, okay? That's called the Bohr model we have right there. And we're going to go ahead and we're going to try to make one for oxygen, all right? And it's going to be a little bit complicated, so I need you guys to hang with me. Write down the steps if you have to. We'll go through a few examples with whatever time I have left, and then if there's more time, I drew 2 more elements up here to remind me because I don't have a periodic table in front of me. All right, so first thing we need to do is find our atom. So you guys are lucky I have it written on the board for me right now. What I need you to do is find the atomic number. Go ahead and find the atomic number. I'll give you a second to find it. Now I'm going to go ahead and tell you. So if you remember, right off the top, that whole number at the top of each box is going to be our atomic number. What makes the atomic number so nice is that the atomic number tells us how many protons the atom has, okay? So I see that oxygen has the atomic number 8. That tells me that it has 8 protons, all right? So I'm going to go ahead, I'm going to draw an example, draw my model. I'm going to draw 8 plus signs. 8 plus signs, 8 positive signs to represent the 8 protons. All right, so we have protons down. We're good to go for that part. Next, what's missing in our nucleus? What's missing at the center of this atom? Well, if you look at this example right here, we had our zeros for our neutrons. So we need to figure out how many neutrons do we have. Okay, so that's where we have a little math coming into play here, all right? So what we need to do is we need to look at our atomic mass, okay? Not our atomic number, our atomic mass, and that's usually written as a decimal. So in this case, our atomic mass is 15.9994. That's a really annoying decimal. And what I told you guys in the last video, typically what we're going to do with the atomic mass is round it to the nearest whole number. So if it's 15.9, okay, we're going to go ahead, we'll just round it to 16. I'll just write 16. All right. And what our atomic mass is, it's basically the amount of protons and neutrons that we have in the nucleus. Okay. So right here it tells us that we're going to have 16 protons and neutrons total. Well, if I look at my picture, I already have 8 protons. So what do I have to add to 8 to get to 16 total? Well, 8 plus 8 is 16, so that means I'm going to have 8 neutrons. All right, so in other words, to find out how many neutrons we have, we take our atomic mass and we subtract the atomic number from it. So I did 16 minus 8, got 8, so that means I have 8 neutrons. So I'm going to go ahead and draw 8 zeros in there. And you're not always going to have the same number of protons and neutrons in an atom. Okay, in fact, most of the time you're not. Most of the time you're going to have more neutrons than protons, but you're just going to have to do some math and science, all right? Okay, next we need electrons, right? The guys moving around on the outside. And electrons in most cases, at least in this class, okay, this year, we're going to say that the amount of protons is always going to be equal to the amount of electrons. All right, so for oxygen we have 8 protons. So we're going to have 8 electrons. And that makes sense, right? If we want this atom to be stable and not crazy, not wild, we want there to be as many positives as there are negatives. Okay, if we have 8 positively charged things, we want to have 8 negatively charged things. Otherwise, we're going to have an atom that's either positively charged, or negatively charged, and it's going to be highly reactive. All right. So first thing I need to do, I need to draw my ring, and you remember that the electrons go around the nucleus. So that's what I have right here. So I'm going to go ahead, I'm going to start drawing 1 electron, 2 electrons, and I'm going to stop there. Because with atoms, the first ring, the first circle you see here, it can only hold 2 electrons. It cannot hold more than 2. So what we're going to go ahead and do, after we fill out the first ring, which only holds two electrons, we're going to make a second ring. Okay, and the second ring can hold 8 electrons. All right, so you're going to need to jot that down. First ring can hold 2. Second ring can hold 8, and then the third ring can also hold 8, and then in some cases up to 18, but we'll say 8, all right? So 2, 8, 8. So I already have 2 electrons in here. Well, that means we said we are going to have 8 electrons, so I need to put my remaining 6 on this ring. Bingo. All right, and one thing to notice real quick is, I mean, in real life, these electrons would be probably off the board. If we're going to zoom in real carefully, okay, there's a lot more space between the nucleus and the electron rings that I'm showing right here, okay? And that's what we talk about with atoms. Most of it's empty space. You see anywhere where you don't have proton, neutron, or electron, it's just nothing. There's nothing there. It's empty space. So this table right here, it's 99% nothing. All right, even though it looks packed in and nice and tight, and like there's no gaps, really it's mostly nothing. So it's just kind of wild. Okay, we're gonna fly through this next one real quick. Okay, on your periodic table, I want you to go ahead and find this. I don't have time to copy it down on my board. Go ahead and find carbon. Go ahead and find carbon. Pause it. If you can't find it, pause it. Okay, and I have carbon right up here, my top left. I don't know if you guys can see it. I have carbon up there. It's number 6 on the periodic table. So again, its atomic number is 6. So that means it's going to have 6 protons. So I'm going to draw 6 plus signs. Okay, 6 plus signs. Now I need to find out how many neutrons there's going to be in that nucleus. Well, let's go to the atomic mass. Okay, the atomic mass is 12.0107. I want to round that to the nearest whole number, so 12.0107, that's just going to be 12. So my atomic mass is 12, atomic number is 6. 12 minus 6 is 6. Okay, so I'm going to have 6 neutrons as well. I told you guys you're normally not going to have the same amount of protons and neutrons. Well, I guess this video is the exception. All right. So now I just need electrons. So since my atomic number was 6, I'm going to have 6 electrons going around. All right, so I'll draw my first ring, fill out as much as I can. So I can fit 2 electrons on that first ring. Now I need to make a second ring. Okay, so I have 2 electrons in, I have 4 more to go. So I'm going to go ahead and put the remaining 4 on there. All right. Bingo. And that's how we would draw carbon. And if I were to just show you a picture of this right here, and I'd say, what element is this? What element did I draw a Bohr model for? All you need to do is just count the plus signs. How many protons do you see? Well, I count 6 plus signs. So I'm thinking, man, there's 6 plus signs. There's 6 protons. That must mean the atomic number is 6. So you go on your periodic table, find number 6, see which element it is. All right, and that'll tell you what element I just drew up here. All right, I am running low on time here. Okay, hope this was helpful. Hope you guys paused and took notes as we went, and I will see you guys in class.